A little bit about myself. I am a freelance data engineer. Rather than tuning existing data processes, my focus has been more on standing up transparent and reproducible workflows. In overly simplified terms, I've used Airflow much more than Spark. And so when I created my hierarchy, I took inspiration from Monica Ragotti's data science hierarchy of needs, which a lot of us may have seen. And Ragotti took inspiration from what we know as Maslow's hierarchy of needs. And just kind of sourcing these ideas where they come from, Maslow took inspiration from his research at the Blackfoot Reservation. According to Psychology Today, the Blackfoot tribe conceive of reality in the form of a teepee made up of different levels that converge into each other. So we can see where these ideas come from, and I believe it is ethical to acknowledge the origin. So we go ideas inspired from the Blackfoot tribe to Maslow's inspired hierarchy of needs, which then led to data science hierarchy of needs. And so when I first looked at this triangle, I knew as a baby data analyst, I knew I spent most of my time in the middle section of aggregate or explore and transform. As the saying goes, 90% of data analysis is data wrangling. So I was spending a lot of the time there, and I knew I wanted to move down further to move, store, and collect, but I didn't have many of the details clear to me. And I knew data engineering was at the bottom, data science was like kind of closer to the top. And so after a few years, I came to this conclusion. I created this triangle on common data engineering needs across all organization sizes. It's definitely not scientific, but I hope it can help any person to build their data engineering practice from the ground up, or moving from manual processes over to a transparent and robust thing. So, why another mental model for data? There's already data ops, ML ops, CI/CD. There's so many. There's so much advice out there, and this is a really fair question. I've tried to make this mental model different by focusing on baselines and fundamentals. So this approach forces us to think on why we would tackle some of these solutions rather than handing out prescriptive advice. And a lot of technical content attempts to impose a scary, complex diagram on top of your business, or it gives you a laundry list of tools. And I'd rather this talk be focused on talking to an audience that's just looking to build in a messy world. We had a dog cameo there. So the first technical topic is automation. And so here we have an example tweet from Casey. She says, let my pain be a lesson. So this is an example of a complete lack of automation because the data processes are like removing rows, removing duplicates, combining CSVs, all these type of tasks that we know, if they're stored within Excel, there's no transparency. And so without transparency, without transparency, the trustworthiness of your data tanks because nobody knows what happened at each stage. So in my opinion, without automation, there is no data engineering. I see our roles as those who enable analysts to be more effective and efficient. And so that's why I chose automation to go first. A company usually starts with a mix of manual processes and click-based software like Excel or emails to work with their data. And a question comes up like, what's a good baseline? And my answer to that is scripts, really. I recommend scripting as many of these predictable processes as you can bear. And I say as you can bear because the ROI in the beginning is really low. If you are moving from Excel to a scripting language, the learning curve is steep, but it is worth it because this is the hardest hurdle to get through. If you can get all your data processes into scripts, you can connect to databases, combine data sets, remove duplicates, everything you could want to achieve in a series of data tasks. I would personally write these scripts in Python because Python is extensible, but I don't begrudge situational factors. So here are some more subjects that a company could strive for when working on automation if they want to build a workflow that is automated from end to end. So infrastructure as code. The way I see it is it's tediously organized shell scripts into the press of a button or a few buttons. And if your data workflows are written into an infrastructure as code tool such as Ansible or Jenkins, internal tooling can be built with what is essentially just a single command. In simpler terms, automation at this level allows your engineers to work on business needs rather than software troubleshooting. And the second layer of automation complexity is data workflow orchestration. When a business data needs become more complex, like they need, if you need dependencies, retries, alerts, Airflow is a great option for this step. Of course, this is Airflow Summit, and I love Airflow for ETL or ELT software. So to go a little bit more into why Airflow is great, I'm sure a lot of people have gone over why they love Airflow, but these are my biggest reasons. I believe Airflow is a great solution for ELT or data orchestration because of its extensibility. And there has been at least one constant in the data industry, and that constant is change. Extensibility enables Airflow to be adaptable to the change that is sure to come. By extensible, I mean engineering talent. Lots of people know Python. It's an analytic standard, so they can pick up Airflow more easily. And on the technical side, you can connect to any data source, a lightweight backend, and perhaps most importantly, has a code as an abstraction layer. So this kind of like goes back to the infrastructure as code idea, in which we're not dependent on a single server, database, or piece of equipment, and our workflow essentially lives in the text of code. Okay, so moving on from automation, those were all like some advanced, some basic levels of automation that a company should tackle. After that, I chose extract, and I chose this as the second one because, as I said earlier, without automation, there is no data engineering, and I believe without extraction, there's no data, there's no ingredients to work with. There's nothing with which to generate business insights. And I recommend getting consistent extracts figured out before optimizing anything down the line. So the only specific recommendations I have here is to utilize no-code solutions when you can. This allows you or your engineers to focus on business needs rather than authentication errors. And if you can't avoid like a really custom data source, you have to write a connection to it. I highly recommend fully automating that in code and not having an in-between solution, which is going to breed problems for technical debt. So on to the third. Let's say we have our data connections all figured out and automated, or click and drag through a tool like Zapier or Retool. After that, we load our data, and I think we can all now confidently say that ETL is dead in favor of ELT. So I recommend loading your raw data into cloud storage in an unchanged and immutable way. You should always load first and then transform. And this is why I say ETL is dead. ELT took its place. We load all of our data first before we make any kind of changes, so that we keep a historical view of our data. And cheaper storage has enabled that because we don't have to worry about duplicating data or storage costs like I say we, but data engineers or ELT people used to have to worry about storage a lot more when storage was more expensive. So storing all of our raw data, it's currently known as a data lake. A data lake is not meant for analysis, but it can be used. You can query. The queries may be a little complex because the data is raw, rough format, and it's all of it. Some more layers of complexity on the load step. Daily snapshots are really important because you want to capture history of your data sources, data set outputs across time. This becomes more important later in the machine learning step as well. But you can avoid painful backfills to try to recapture a long gone analysis. And the sooner you can get started on this bullet point, the better. And I have a link there, which will the slides will be available later. So speaking of daily snapshots, an awesome solution for large scale and long term storage is Parquet files. They use columnar storage, which optimizes for analytics and are queryable. And Parquet files can also help solve a data lineage problem by keeping track of your metadata over time, all while staying within the extensible Python and SQL ecosystem that we all know with Airflow. And one heuristic that has helped me with Parquet files is that if you can think of CSVs as software and databases as hardware, Parquet files is kind of in between. A firmware in which you are still able to query like a database at a database speed, but it has the flexibility of files so that you can just store them on like S3 storage. So after you have connected your sources, you're loading into a data lake. Maybe you're even doing daily snapshots. After that, I would recommend focusing on transformation. And I made a distinction here between 4 and 5 of transform and optimize analysis for a specific reason. And I wanted to keep level 4 transform focused only on fundamental SQL statements. It's moderately arbitrary, but I believe I have good reasons for keeping SQL kind of in its own level. And the first reason is maintainability. Chris Marati wrote in Stitch Fix Algo blog about using simple SQL tasks as much as possible, because more people are likely to know SQL in an organization than a given scripting language. The invisible benefits of shared learning, shared debugging play a role in building robust insights. So that's why I'm such a proponent of SQL, at least at the fundamental transform layer. And there are a lot of business problems that can be solved with SQL alone. Here's one of them: data silos. If an analyst has to email someone for access to a data set, that is bad. I recommend Presto, which is a open source universal database query engine to remove data silos. An analyst that can write SQL should be able to access the data and not have these data silos and have people as blockers. It slows down the organization for sure. Another problem you can tackle on SQL alone is parameterizing your basic SQL transformations to meet your business needs, so that your infrastructure produces as many data sets, quality data sets as possible. So I recommend using DBT or data build tool to parameterize your SQL. And here's an example of a SQL template. I personally have more experience parameterizing SQL in Airflow using the Jinja templating. I've spent many hours on the macros documentation page on Airflow, and so it's a lot of these similar topics, but applied to SQL. So we want to be able to produce data sets that analysts can query. And a lot of times we have like common queries that we might want to use. And so putting them into templates and inputting these business parameters that only matter to the business allows these data sets to be created in a more streamlined process. So for example, taking this query of select templated columns from table, templated where condition. So let's say for a business, the user who is querying really matters a lot. And so someone with low permissions would have a maximized where conditions and a minimized number of columns selected. But someone who has all the permissions and is executing the same query or the same template might have no where condition at all and all of the columns selected. And so this is just an example of what might matter to a business. The main thing is that the business decides what matters to them, and they can decide how to parameterize their SQL based on that. And finally, on SQL alone, data quality testing is so important. Doing column-wise or table-wise assertions at the SQL level allows you to stay within this like SQL Python ecosystem that I've mentioned. And it's critical for reducing pipeline debt, which is a phrase I've 100% stolen from Great Expectations, which is a tool for data quality testing. And I like that tool because the tests are in JSON, they're easy to understand, and um, and like I said, they're column wise and table wise operations. So after SQL, I put optimize analysis. Uh, the next level in the hierarchy is to optimize analysis. I take this to mean that you're going beyond the fundamentals of SQL. Spark is great because it splits up your tasks across many smaller machines rather than throwing the whole thing at a single machine. Another area that you may optimize analysis beyond fundamental SQL is custom data transformations. So Jupyter Notebooks is great for prototyping analysis that you might want to push to production. Another avenue for um, optimization is to reduce computational costs. And I've seen this growing in popularity at larger organizations. And I definitely see this as kind of the future of data engineering, focusing on systems engineering, looking at the processes um, at a more with a more critical eye rather than just writing whatever works in Python. And so, second to last, I put machine learning. If a company has gone up to this point in my hierarchy without any machine learning models, but they somehow executed steps 1 through 5 with great discipline, they would still have they still have access to timely and quality business insights from data sets being created. So lots of bar charts and line graphs at this point, which are um, kind of like solve a lot of the biggest problems that data teams are trying to tackle. Machine learning comes after this, and this is I promise this is the only scary diagram in this whole talk. And this scary diagram is from Google Cloud's documentation on an automated machine learning pipeline. It's a bit more complex than how I tend to think about things, but I think I wanted to draw attention to the bottom right hand corner, in which we see here data is being trained in an automated pipeline, and the model is served into into our product. And so that product generates data, which then we create a model, which is then served to the product. And we see this quick feedback loop that is not as apparent in other data processes. And I think that's worth pointing out. This makes, if you're getting to this point, it makes data lineage, metadata tracking so much more important because you could um, muddy the waters with your prediction services. But yeah, finally, there are streaming. There are companies like Repay that are using streaming to create like a frictionless product across payments. But I'm not definitely not talking about use cases like that. When I put streaming as last as priority, I'm really just talking about data analysis. So streaming for analytics is not very common. If I find it confusing when I used to see data engineering job openings with Kafka in the requirements, um, especially if Kafka isn't used as a data source for at the analytics level. Um, I can definitely see this growing in popularity in the very far future as we like figure out how to look back in the past. But I think we're kind of stuck with bigger problems right now. So, in conclusion, going over the big whys, why even go over these topics? And so, I believe transparency enables data integrity, and reproducibility enables data quality. Without both data quality and integrity, your business insights are simply not sound. Um, and perhaps a more important reason for building transparent and reproducible infrastructure is ethics. An ethically challenged analysis has a much harder time standing in an environment of transparent and reproducible workflows. Ethics are important, and these principles enable organizations to do the right thing with their data. So I have nothing to promote except my Twitter account. Or no, I'm not even my Twitter account. I don't want to see my boss to see that. Um, I don't have any side projects that I want to promote. I mean, I have some writing up, and if you would like to contact me for any reason, I have my email there. Say hi, ask questions, but that's pretty much it for me.
My own plug for a book I just read. I really like that you talked about the ethics and the transparency of it. There's a book by Kathy O'Neill called Weapons of Mass Destruction. And she talks about what she calls black box algorithms, where you just can't see into it and how they can be very unethical if you can't justify what's going on under the hood. Okay, another question. In the ETL process, we usually extract the data, then transform it, and after that, we finally load it. So when ELT takes place, then after loading data, we transform it. So isn't it an infeasible thing?
I think so. To rephrase that question, um, your current process is ETL, in which you extract, transform, and then load. I'm assuming into like a data warehouse of some kind. Um, I think what I'm recommending is to not transform right away after extracting, but rather um, when you extract, just load what do a like a select star load into your storage. So load everything so that your data sets are immutable and unchanged from source. And then from there, you can do a transformation and then load into your destination, which would probably be a data warehouse.
Cool. I'm not seeing any other questions, but I'm going to give them a few more minutes to come in. One of my favorite questions is, do you have a favorite Airflow operator?
Uh, probably Postgres operator because it's very simple. It has like 3 or 4 arguments, right? So you pass in a SQL string or a list of strings, your database connection, and then like the tag or task ID. And so it's very. I love how simple it is. Yeah.
Nice. All right, we have another question. Could you elaborate on what type of work you mean by systems engineering, maybe with a specific example?
Absolutely. So let's say, hmm, so this is systems engineering can be kind of abstracted into like programming languages like C, C++, or Rust. So if you wanted to take that route, but um, a specific example of data or systems engineering, I think looking at how processes perform across different size of data sets. So if you're doing joins between a small data set and a big data set, partitioning both doesn't make sense. And so that's to the point where you're going into the lower levels of system engineering, kind of deciding what the processes do under the hood rather than um, taking it for granted or just kind of like dot join, right? And so whatever happens in the background, but then looking to optimize that, maybe we don't. We have two data sets to join, right? One small, one large. Maybe we don't partition the small one, but store it in memory so that it could be accessed very quickly to join across the big data set, which is partitioned as normal in like a Hadoop or Parquet like file parts. And so that kind of like looking under the hood, seeing what you can optimize in terms of computational costs is what I meant by systems engineering.
Cool. Thank you. Um, I don't see any other questions at the moment, but if you do have more questions, you should put them in the Airflow Summit attendees Slack, and Angel may see them later today. So if we have no more questions, I think we should all in our respective, we have one more question. I was hoping that if I drew it out long enough, one would come in. So did you build anything custom to extend Airflow?
I don't believe so. Um, I have no, I don't think so. I've kind of just used um, whatever comes out of the box.
Nice. Well, if you do, and it's really cool, you should contribute it back. All right. Well, with that, let us all from our respective areas give Angel a big round of applause. Thank you so much for your talk today. The
Thank you.
next session will begin at the top of the hour. And oh man, one other question. Everyone's killing me, but these are great questions. Um, any specific macro you have found especially useful?
Yeah. So the DS or dates, I think it's DS is the shortcut for date stamp. Um, Macro has been really useful for backfilling data sources. So I throw in a DS into my SQL query, and so that I can loop through previous dates. Um, and or actually not loop. Airflow does that with the scheduler. So yeah, using a scheduler and the DS macro in conjunction has been really useful.
Excellent. There's one question I saw from Kakshil in the Slack, and it was, oh, he got rid of it, but I'll ask it anyway because I'll pretend it's from me. Is there anything you're excited about in Airflow 2.0 that you've been paying attention to?
Um, Honestly, I wouldn't be able to answer that question.
No
I
worries.
am excited, but I don't have anything in particular. I haven't been keeping up. I've been too busy.